This presentation we will discuss the basics of identification systems as deployed into the manufacturing arena. Why do we at all need identification systems in automation? Well, part of the smart sensor discussion we had seen that for an automation system to work effectively, not only does it need to detect, it needs to measure. It also needs nowadays to characterize the target, read the target, the information embedded and related to the target. Not only read, but write back the information regarding the process, the station, the job or the target is undergoing. The advantage of that is it reduces human error. The logging system is digitized, so the speeds are higher, the efficiency becomes better, and digitized transparency of the entire job work or the process is enhanced to a significant degree. I would say some of the very salient benefits that are being derived through identification systems as deployed in automation is reduction of error, thereby leading to a lot of cost avoidance. It's a manual rework cost and the labor cost, the repetitive stress injury, because something that is repetitive in nature will get monotonous, thereby letting a huge door open for human error. Improved productivity through wireless inventory management, faster check-in and out, prevention of leakages and theft, quick correlation of inventory audits, weeding, quick search, quick locating, track and trace applications, and thereafter a very good collective management of collection through again I would say inventory controls, track and trace, supply chain. All of that goes a long way into embedding information through identification system in a automated arena. How do you really do that? You can either have magnetic strips and credit cards, that's one way of identifying information, electromagnetic or a radio frequency identification. Examples are like those in automotive, or very simple barcodes, which are primarily, as you see, in consumer goods. In fact, the best example of identification system or the ease of use and efficacy of an identification system is commercial barcoded goods. Quick capture of information, quick processing, quick data table correlations, and thereafter trigger of the subsequent process. So same things you can actually draw an analogy in an industrial world on a shop floor. How things are characterized, quickly information is driven through radio frequency or through barcodes, as we would subsequently see. Therefore, an ADC or automated data collection, that's the other, I would say, synonym of identification system. But when it uses radio frequency waves to communicate and transfer back and forth data between a reader and a movable item, which is categorized through a tag, if I may say, to jump the gun, you would subsequently see. So, wireless, but through radio frequency cross exchange or reading and writing of the data is RFID. But if the same thing is done through, let's say, optical medium like barcode or a biometric system, it's optical identification and sometimes it's camera based identification. And this presentation we would try to actually do some preliminary investigations into these technologies. As you can see, RFID is an automated data capture technology, electronic identification, tracking, storing. What really happens is that a tag primarily, which is, you can say, a child part, and if the reader is a mother part, the reader is actually all the time in face of the event trying to read the data from the child part, the tag. The efficacy of the system lies on what form factor is the tag in. Is it a paper or is it a epoxy? Is it embedded in Teflon? Become part of the process. How far the reading is enhanced or attenuated with the reader in an industrial application, which form factor, which material comes to play actually decides what kind of RFID system we would use. Pictorially, a RFID tag transmits information to a RF antenna, which, with the help of back-end electronics as a RFID reader, is picked up, filtered. The carrier is separated with the information, digitized, and then through a wireless or a wired network communicated back to the control or the workstation. So that's how a workstation actually interacts with a carrier which might carry the RFID tag. How does it work? Well, uh, any chip on, let's say, the tag has pre-recorded information. So what really happens is when you energize the power source related to this tag, and when the tag, the chip, the electronic circuit sees the carrier waves present, then it responds along that carrier frequency and carrier wave to start broadcasting the pre-written information within the tag, which the reader, depending on the power it's configured for, sees the digitized information riding on the back of the modulated waves. Therefore, it takes these modulated waves, demodulates them, separates the carrier wave from a digitized signal, filters the digital signal, bit checks it, and then pushes it back into the network. Going to the history, well, as the picture says, the first RFID application was the identification of a friend or an enemy, used in the Second World War, done primarily through radars. But then it morphed into anti-theft systems in 70s, low frequency RFIDs, that's what I would call. You can see them in action even today on consumer goods, shopping centers as anti-theft. But industrially speaking, it was the 80s when RFID was directly deployed for identification of vehicles so that they could be taxed. In other ways, it was on a toll collection. So toll collection was one of the very first applications of RFIDs in a long range and a big commercial application, so to say. But what started changing was that when the information recorded on the tags was starting to get organized and different carrier waves and microelectronics started helping modulation, demodulation, mass production of microelectronics leading to very, very economic chips on board. That's when really the RFID took off and found a very potent place in industrial applications. The general capabilities of RFID systems, as you would see, are read the data without a visual access within the lobe of the signal, so called, from the reader. Therefore something may not be in a direct visual contact, but the information is still accessible. Reading the data on the fly, that means the target need not stop, communicate and move. It can keep moving, and that became a very important aspect for deployment into the manufacturing systems. Then the reading distance. Industrially speaking, it can be few centimeters to probably these days about 10 meters, but then the bigger commercial applications like seaport, harbors, cranes, long range systems, you'll see subsequently, depending on the tag being active or passive, go up to a range of 100 meters. Then the security of the tag data, that means the chip is not only giving digitized information, it's encrypted information. So this encryption and decryption makes the entire system more secure, so that even the pilferage of data and hacking is also avoided. Then ability to write back in barcode systems, as you would imagine, one can only read but cannot write back. Like in manufacturing system, when a job work carrying RFID tags moves from one station to the other station, what work has been done on each station, what parameterization has been done, which operator was there, so to say, can also, depending on the need, the information be written back into the tag, which is subsequently becoming a storehouse of a lot of information of all the processes it has gone through. Or even diagnostic data during manufacturing of an item can be written back and categorized and related to the item. Again, form factors, applicability, general environmental conditions, etc. make RFID to be more potent. Something very important is that there's a correlation between what is the frequency of operation of different RFID systems. These days, about 4 such bands are primarily active. Low frequency systems, as you can see, somewhere around 125 kilohertz. High frequency around 13.56. Ultra high frequencies, which are 860 to 930 megahertz. It's actually quite close to GSM, so you require licenses. Industrially speaking, it's 865.5 to 867.5 megahertz in India, with 4 channels per delta change of hertz, single hertz in India. Also the energy factor, how much energy is allowed to be emitted from such a reader. Similar conditions apply to microwave, where 2.45 and 5.8 gigahertz systems are open to industrial applications. But basically the difference between low frequency, high frequency systems and the otherwise UHF and microwave are the reading distances. Because high frequencies are able to give us larger reading and writing distances than their counterpart in low or a HF range. Herein we have given some direct comparisons, advantages and disadvantages of each kind of RFID band of operation, giving a clear guidance to where most effectively such systems are deployed. Like if you use a 2.45 gigahertz system, it's owing to a large read-write range, more appropriate for vehicle access, people access, and asset management, whereas the low frequency 125 kilohertz is more related to object identification, inventory control, segregation. In fact, with the larger antenna having increased the range, most of the anti-theft system you are seeing commercially available in all the shopping centers are largely 125 kilohertz low frequency systems. But in production floors, generally speaking, it is the HF system which offers us slightly better range, but also certain capabilities with a lower size form factor, lower geometry of antenna but higher frequency, giving us again the appropriate range. Whereas in low frequencies, your antenna size starts getting bigger with range. Something which UHF systems are actually more exemplary in multiple tag reading over long distances. So you can see them better deployed in tracking, tracing, material handling, and very familiar toll collection. So the main components, as we have discussed, are RFID tag, also known as a transponder, standardized chips on a transponder, antenna with which basically the modulated wave communication takes place, and a transceiver which may be integrated with the antenna, or the antenna might be separate from a transceiver depending on the condition. Sometimes a transceiver is able to handle multiple antennas also in different configurations, thereby giving us much larger access to data points that are strewn around, or tags that are strewn around. So herein you are seeing the functionality of the readers, which are able to pick up the signals from the antennas and communicate back to the digitized systems, controllers, PCs. And a lot of times battery powered readers can be handheld for a quick check. Readers can be agile, intelligent, or dumb. That means depending on the deployment. Uh, As the word explained, agility of a reader is multiple tag readings at different frequencies using different methods of communication between tags and readers. These are multi-point utilities, and running a lot of protocols, filtering the data from a pre-defined lookup table, giving a part decision on detection, go no go conditions, and sometimes just reading only one type of tag, unfortunately called in parlance as dumb readers, but single point readers. Tags, as you would see, sometimes they are disposable tags in high frequency ranges, but industrially speaking, most of the tags are reusable ones in proper Teflon or a PVC coat. Uh, Sometimes on carriers, metal carriers, again, the engineering is predefined on such what kind of ranges, what kind of signal attenuation, what kind of metal interferences happen. All these are pre-engineered, and different tags with different geometries can give different range of reading with the same readers, or different speeds with which data is read, or different speeds of movement of the tags. Generally speaking, larger the tag, better the sensing distance, bigger the size of the antenna on the tag. But again, tags can also be of three types: passive, semi-passive, and active. Passive tag has actually no internal power supply. Whenever the incoming carrier waves are detected, they are enough to charge the antenna with a small capacitor inbuilt, which stores the energy and activates the chip. And once this chip is activated, the broadcast takes place. As soon as the tag moves away from the field, the power dies down. Such a tag has an unlimited life, limited range, and usually are small in size. Semi-passive tags, on the other hand, are endowed with a small additional battery which is powering up the circuit. The power is drawn only when the carrier waves are seen, but since it's powered up separately, it is able to give a longer range, but again its life is limited by the life of the battery. Last but not the least, the active tags have their internal power source. and these are more beaming, they are transmitting constantly. One big best example is active tags on sea containers. You must have seen big seaports, sea containers are lying around, and each of the container actually has a transponder, a tag that's constantly transmitting its information. uh, it's also a beacon, as you would say, that is collected by a lot of readers spread throughout an arena. Now you see the efficacy that each container tag not only has a container serial number but might contain a lot of information about the shipments, the sub cartonization, sub pallets being carried in the container. So uh, thereby it becomes a very powerful media to transmit information very efficiently without error over long distances, over commonalized data highways. So here again you are seeing a comparison. The point to take home is generally the batteries in active tags are lasting 2 to 7 years, and in passive tag about 10 years. But it all depends on the temperature, the usage cycles, and so on and so forth. The best are single ID read-only tags, that a tag ID can never be changed. Once it's assigned, it's written into the chip. It's unique all over the world. Warm tags, written once and read many times. That is, as many times as possible, the data can be read, but never rewritten. But the other kinds are the read write tags, where tag ID, one is a main ID, but then acquired ID can also be given, which can be changed over a period of time. But then one can have 8 kilobyte, 32 kilobyte, 64 kilobyte, 256 kilobytes, and sometimes even up to 4 megabytes of information written in a tag. An important part to be remembered is that such ID systems also are categorized according to their principle of operation. Primarily speaking, you can have an inductive principle working in industrial domain, a microwave, as you would imagine. Alternatively, optical identification system, which is largely the barcodes as we generally know. But then industrially speaking, you can also have a photo array with barcoded strips and camera based identification, which we will see in subsequent slides. Here again, from laws of electromagnetic induction, it's the inductive principle that comes into play, wherein on a close proximity of an antenna, the field being emanated by the antenna is picked up by the RFID tag, thereby energizing the ICI, the microprocessor inside. Very simple as explained, but inductive RFID are endowed with smaller ranges because the electromagnetic field, inductive electromagnetic field, do have a very limited range on this. If you come across a microwave system, uh, it is actually able to travel longer distances. Most of the microwave systems, the tag have their own energy source, generally speaking, a passive or an active tag. And depending on the local regulation, how many milliwatts of energy of microwave a reader can transmit, uh, their ranges can be approximately 2 to 3 meters generally speaking, but extendable up to 6 meters provided one doesn't breach the power safety requirements of the radiation. Electronic product code is, I would say, a very necessary part of our RFID reading, where how the information, the data is organized and how do we derive uniqueness of the product code is a protocol so that we don't end up duplicating things, make them cross readable across manufacturers and equipments so that the consumer can derive a better utility of the product so used. Very worthwhile to see some applications of RFID. Some pictures are self-explanatory here. As you going into industrial, I would say warehouse management and logistics is one of the very evident and immediate application of long range RFIDs, so that destination alert, content information, mapping of pallets to stations, piece part, piece to product, product to carton, child carton to mother carton, everything can be correlated, married into each other so that all these subsequent handling are mapped and probability of error thereby drastically reduces. However, within the assembly line, if the job work is tagged with RFID, the sorting, managing the job work, uh, let's say some component moving on a conveyor line, it needs to be drilled or not drilled. How does the operator know? Some identification has to be there, but in an automated human-free system, how does the machine know? Therefore, even after detecting, the characterization of the tag actually gives the information to the read head of that particular job vertical, what needs to be done with that particular target job, I would say. Again, asset identification, asset tracking. Very early uses was animal identification. Talking about industry, dairy industry largely used RFID tags for animal identification, and which was even boiling down to product categorization. Something very familiar we are in the public domain is library management, security and access. And these days, in fact, per ARAI and Surface Transport Ministry, all four-wheelers, private and commercial, are pre-fitted with RFID tags for quick, I would say, identification and mapping. Which tool to use in a tool changer robotic arm, which tool to use in which particular job, either one programs it sequentially or endows it with a RFID tag so that the read head which is mounted on the robot can read, verify, and then engage the particular tool for a particular job. This application, I believe, is one of the very, very widely applied solutions for high-end automation. The way bridges, how do we characterize a truck to the information so mapped? Cement container mapping is very evident. Mold identification, infrastructure, how does the goods produced are then distributed. In fact, these days, blockchain and genealogy applications, uh, RFID or the identification are the basic backbone for such systems. Coming to optical identification, most of us actually have seen that and maybe also used and deployed in many of our projects. Uh, Basically, an imagery out of the captured light can be an analogy to an information, so to speak, relating to 2D barcodes, as you would say. Barcodes again are following a lot of standards. Thickness of the barcode depicts a digitized code. Even the spacing between the bars embeds a second layer of information. So if we are able to scan this, picturize this, and digitally break it down to information and decode it, having mapped a particular standard of barcode, having decoded a picture, very easy to characterize the code embedded into such an optical barcode. Dimension barcodes, uh, QR code, a quick reference code, is no stranger to us these days, which actually carries the same barcodes but in two dimensions. A lot of ruggedity and miniaturization has been built in because of the 2D barcodes. In fact, a lot of industrial parts are today etched with 2D barcodes. Uh, in fact, one of the beauty of 2D barcodes is that even with a partially damaged 2D barcode, the recreation within the reading and recreation of the code within the controllers is actually very handy and very useful. Again, like 1D barcode, even 2D barcodes are on a standardized format. The readers, however, on a barcode, you can have a single line scan of a barcode, or commercially speaking, if you see, you would see a lot of crisscross red laser lines falling from a reader onto the barcode that we call as raster scan. This is the same incident light but with rotating mirrors oriented around different angles, multiplying the angle of incidences and the zone on which this scanning light falls, even with a single capture, taking out the barcode reading or barcode image from multiple angles so that the user doesn't have to actually tilt, rotate anything, but by itself the image is captured from different angles and reduced to come at the right code in the fastest time. Herein you can also see that barcode scanner 1D or 2D barcodes, how they are being put as a 2D matrix code as well, and difference in intensity actually is giving us the pulsating signal as in the center, how the scanner actually reads a barcode. Again, we would have seen commercial barcodes, but industrial barcodes are all along the assembly lines. As you can see in the central picture, industrial online barcode reader directly reading the code on the bin, thereby moving along a conveyor. A lot of times these days, online barcodes reading up to 1 meter, sometimes even 2 meters, are endowed with a small vision camera with its own illumination, because an image is an image as captured with a camera, but then the control software really deduces the right code on such a. Some applications of optical ID to go through again: tracking, tolling, medical record keeping, drug dispensing. In fact, in the automotive industry, characterization of all inventory items through barcode, I think it had been made compulsory a few years back, so that portability of information across different enterprises and systems is also done seamlessly. Production line control and also mobile applications with handheld applications. In fact, our all powerful smart mobile systems are endowed with a camera and also the barcode software, so that they are effectively as well a ready barcode reading station. Very necessary to understand what is the difference between a RFID and a barcoding system. Both of them come with their own pros and cons, but I guess one of the basic differences remains that a tag can be housed in a more rugged housing and subjected to a lot of different processes, which is not possible with a barcoding system where optical readability has to be maintained for the system to function. Importantly, in bigger systems, we can have such barcodes oriented around punched metal strips, which are then read through a photo array. Same functionality derived, but mutated to bigger systems on more rugged systems, so to say, industrially speaking. System that has been used and deployed in bigger industries, difficult process industries, wanting industries where chemical or temperature issues are paramount and still things need to be identified. You can see a thin metal plate with drilled hole patterns. So just like a 2D barcode, the metal plate can be drilled, etched with such patterns, and the reader, through its visual systems, a vision system, can capture such images, because if the pattern is carried by a Teflon plate, can be used in chemically corrosive environments, and still the pellets and carriers can be detected in high temperature applications where electronics will not survive. Such kind of passive apparatus with pre-built pattern can be used. Means that it's only a read-only system. One cannot write back into the pattern as you would imagine. That's how it works. You are seeing a car assembly skid being moved. Underneath the skid is a metal plate read effectively by a camera so that the skid is characterized at all points of time. The sensor triggers it, the camera comes into the position live, checks the plate, flashing of the light, capturing of the image, and the information as read given back to the controllers. Demodulate the information. Here you are seeing a live example, the photograph of an actual application of how this has been applied in a difficult industry. Last but not the least, even human characterization through such ID systems is possible. Again, capturing of the image, processing of the image, all around pixel imagery related to a fingerprint, pixel imagery related to a iris scan, a facial recognition. Lot many times how ID systems provide service through the entire value chain. Depending on the problem set in a manufacturing process, ID systems can be effectively deployed to derive the value, so to speak. Whether it's a business application or a middleware management or a EPC services or enterprise application integration, you would see all kinds of solutions built around such ID systems. Your attention. I hope we did gather some facts about ID systems and their deployment into the manufacturing area. Namaskar.